Hello, in this video I'm going to talk about substitution of variables in integrals and integration using partial fractions. Now regarding partial fractions, there are other videos where I use this technique of integration that you can watch if you like. Now here I'm integrating I, which is integral of 2 cosine theta over sine squared theta plus 3 sine theta minus 4 d theta. Now, if you can see, I have a fraction here, but this cannot be considered as a fraction of polynomials because these are not polynomials. Polynomials are the variable x, u, whatever it is, and it's a polynomial of this variable. So if I had x squared plus 3x minus 4 here, this is would be considered as a polynomial, and then this would be considered as a fraction of polynomials. But under the form of this form where we have cosine and sine, this is not a fraction of polynomials. But what we can do is that we can do a substitution to make it a fraction of polynomials. So what we do is that we substitute sine theta by x. So we let x be sine theta. Now, always when we substitute with a new variable, which is x here, x is my new variable, the first thing that we do is that we find dx. Now, dx is going to be the derivative of sine theta, which is cosine theta d theta. Or if you want, basically, this is written as dx over d theta because I'm deriving with respect to the variable. I'm deriving x, which is a function of theta, with respect to the variable theta, which is now is going to be cosine theta, which means dx is cosine theta d theta. Now, here in the numerator, we have cosine theta d theta. So this is going to be my dx. So our integral I would become 2 dx, because cosine theta d theta is dx, over x squared, because sine theta is x, so sine squared is x squared, plus 3x minus 4. So now I have a fraction of polynomials, which is a proper fraction because I have a degree 0 in the numerator and degree 2 in the denominator. To solve this integral, I have to decompose it into partial fractions. So first of all, I need to find the roots of the denominator, the roots of x squared plus 3x minus 4, which is a second degree polynomial, ax squared plus bx plus c. Either you say that a plus b plus c is equal to 0, which means the roots would be 1 and c over a. C over a, it's minus 4 over 1, so it's minus 4. Or you can find delta, which is b squared minus 4ac, which is 25. So the roots would be minus b, so minus 3, plus minus square root of delta. 5 here is the square root of delta, so square root of 25, which is 5, over 2a, which is 2, and again the roots are 1 and minus 4, which means the denominator can be written as x minus 1 factor of x plus 4. So we have now our fraction becomes 2 over x minus 1 factor of x plus 4. This can be decomposed into two partial fractions, which are a over x minus 1 plus b over x plus 4. Again, I remind you that when we decompose into partial fractions, the numerator in the partial fraction is 1 degree less than the denominator. So here, if the denominator is a linear factor, so of degree 1, here I should have a degree 0. So these should be constants. Now, when the denominator in the partial fraction is a linear factor, like these two cases, I can find A and B by the cover up method. Now, I'm going to explain it a bit quickly here, but you can check my video about the cover up method if you want it in details. But if I want to find A, I cover its denominator in the left-hand side here. So I cover x minus 1, or I delete it. And in what remains, so in 2 over x plus 4, I replace x by 1, because 1 is the number that makes x minus 1 0. So I get 2 over 1 plus 4, which is 2 over 5. Same idea for B. I cover x plus 4. I replace in the remainder x by minus 4. I get minus 2 over 5. So now my fraction of polynomials became 2 over 5 over x minus 1 minus 2 over 5 over x plus 4. So the integral became integral of 2 over 5 over x minus 1 minus 2 over 5 over x plus 4. I can take 2 over 5 into factor. So I get 2 over 5 integral of 1 over x minus 1 minus 1 over x plus 4. These two are of the form u prime over u, because the derivative of x minus 1 is 1, and also the derivative of x plus 4 is 1. So both of these are of the form u prime over u, which means that their integral are both ln u. Let me get these out of the way. So when I solve the integral, I will get 2 over 5 ln absolute value of x minus 1 minus ln absolute value of x plus 4. More details about integrating the form u prime over u, you can watch it in another video if you want. Now, don't forget that at the beginning, we made a substitution. So we said x is going to be sine theta. So the integral that I'm solving is this one, which is a function, which is an integral function of theta. So the final answer should be with respect to the variable theta, not the substitution variable, which is x. So I have to go back to theta. So I replace x by sine theta. And since I have ln here, if you want ln A minus ln B, which is ln A over B, my final answer is going to be 2 over 5 ln sine theta, because I replaced x by sine theta minus 1 over sine theta plus 4 plus a constant c. Do not forget to subscribe to our channel. Thank you for watching.